Unit 4 in Animal Science checks in and we'll cover animal nutrition, chapters 15 through 17 in your text. The next slide covers the objectives and you all can check on those, but I've split this recording into two pieces to shorten them up a little bit for you. So part 1 of the animal nutrition unit 4 is going to cover topics of nutrients, feed analysis, and then feeds and composition, and we'll cover the second part in another recording. When we look at nutrients, we define feed as anything that functions to support life. We split up into concentrates and refuges, and concentrates are generally considered any feed that is very concentrated in nutrients, so it doesn't take very much for us to achieve some of the nutritional profiles and support that we're looking for. Roughage is obviously then a little less nutrient dense, but yet provide a lot of very specific and important fiber components. 6 basic classes are listed at the bottom of the slide here. Number 1, water; 2, carbohydrates; 3, fats; 4, proteins; 5, minerals; and 6, vitamins, and we'll get into each of those specifically. Water is absolutely and unquestionably the most important nutrient that we're going to talk about. The 4 main functions of water are listed here at the bottom of the slide, but I can't stress enough how important feeding water is to your livestock and having total access to water nearly all the time. And it's absolutely crucial to support digestion and metabolic function of the feeds that are there, but also, of course, to help cool, transport nutrients, and gives the body its shape. And we'll talk more about moisture as we go along. The second one that we'll hit on a bit is called carbohydrates. It's found both in plant and animal nutrition, plant and animal tissue. It's simple. Could be classified as simple carbohydrates, which is like starch. Starch is very, very easily digested. You'll find starch, for example, in very high quantities in whole-shelled corn, products like wheat, products like potatoes would be high in starch. Very, very easily digested when they hit the gut. Complex carbohydrates then would include things like cellulose or lignin, which are critical energy sources and primarily present in cell walls, though it does take animals a bit more effort to break down those cell walls in order to get at that complex carbohydrate. Fats are included next in this slideshow, and we talk about they may be considered oils as well, or you may also know them as lipids. And the difference between a fat and an oil is listed here on this slide, just depending on what state they're in at room temperature. The important thing about fats on this slide is fats are 2¼ times more energy dense than the same pound of carbohydrate. So when you look at adding fat to a diet, you may reach a situation or a scenario where there's not enough energy in the diet to support the kind of average daily gain or milk production or whatever it might be. And the animal can't physically eat a whole lot more feed, but we can include fat in the diet in order for them to help meet that energy demand. Plus, also, animals do have a fat requirement. It's needed in many cases to absorb things like vitamins that we'll talk about later on. Proteins get a lot of interest, and partly because they're the most expensive feed ingredient that we will put in the diet. But we look at proteins like simple amino acids, simple proteins that are made up of very short chains of amino acids, always very critical that we talk about amino acid feeding, all the way to complex proteins that are bigger proteins. They might be things like immunoglobulins or antibodies, or things like what's listed here on the slide, glycoproteins, which is a protein hooked to glucose, or a protein hooked to a fat molecule, which is a lipoprotein, and so forth. This is the only nutrient class that contains nitrogen. And when we consider protein, we're really looking at the amount of nitrogen in the feed, because we can't test for crude protein content. We test actually for nitrogen, and we take that nitrogen analysis. Let's say it's 3% nitrogen, and we multiply it by a factor of 6.25, and that tells us the percent crude protein in the feed. So that would be about 18 or 18.75 to be more specific. A second slide on proteins here, and really one of the things that we key more and more in all the time is essential amino acid feeding. Animals really digest and absorb amino acids, not proteins. So whenever we have essential amino acids, those are those are amino acids that must be supplied in the diet because the animal can't get enough of them. So things like lysine in pigs is a very important amino acid that we need to feed in the diet, and it'll actually make them much more efficient, gain more effectively, and actually cuts our costs. Various absorption rates for protein, and you think about complexity of the protein. Egg proteins are the least complex. Milk proteins also very simple type of protein. So the peptide bonds are very easy to break, and it's very simple for your animal to absorb than the amino acids that are there. All the way down to plant proteins, which take quite a bit more time to break those peptide bonds down and make it available for absorption into the gut. Minerals then are listed next. We'll break down or subcategorize minerals into macrominerals and microminerals. The biggest difference between these two folks is macrominerals are fed in larger quantities, microminerals are fed in smaller quantities. There's really no difference in importance. You need all of them that we'll talk about. So examples of macrominerals would be calcium, phosphorus, potassium, magnesium, sodium, chlorine, sulfur. Microminerals, for example, we might be looking at items like molybdenum, manganese, iodine, iron, zinc, cobalt, things of that nature, selenium, that are very critical and function also very, very importantly. But we have to make sure that we have proper mineral balance and function into the diet for animals to maybe reproduce, maybe make hormones, things of that nature. Keep in mind, overfeeding minerals is not a good idea because they can be actually harmful or even toxic if they're fed at extremely high levels. Vitamins, then, the last of the nutrients that we'll talk about. 16 of them that are really important, and most importantly for you, they're subcategorized again like we've done a lot of different things so far in this component of the lecture. Is they're fat soluble or water soluble, and what that means is they either have to be in the presence of fat or water to be absorbed into the gut. So fat soluble vitamins are listed there, the A, D, E, and K. Water solubles are like your B complex vitamins and vitamin C. In ruminants, we do get a good bit of synthesis of those vitamins in the rumen. The microbes will actually make them for us, which is quite handy. Some other things that are non-nutritive in nature, things like antibiotics that we might be adding to the gut or adding to the feed in order to prevent some challenges that may occur in terms of health, or coloring agents, or something of a flavor enhancer, a dewormer of some kind. I say be aware of new veterinary feeding directive requirements because anymore you need a prescription to put many of those things into your feed. So consult with your feed nutrition professional as well as your veterinarian to make sure that you have all your paperwork in line. Feed analysis then is extremely important when we talk about building effective rations. We want to make sure that we take samples of feeds and send them to the laboratory to get components measured like what's listed here on the slide, and there's many more depending on how much money you want to spend on an analysis, but we have to know exactly what's in the feed before we can build an effective ration. Now when we talk about feeding things like corn or soybean or a packaged feed that you buy at the store, that's already been done for you behind the scenes. The feed company always does its own quality assurance and checks those things for itself. But if you're feeding hay or corn silage or alfalfa haylage or baleage on the farm, it's a great idea for you to work with your feed nutrition professional and get an analysis done of those feeds on a regular basis so that you may make sure that your ration is as exact as it can be. It will save you money in the long run. They'll look at things not only like the nutrient issues that we talked about, they'll look at feed digestibility, how well it will be digested in whatever species gut that we're feeding it to. They'll evaluate it for energy and of course proteins and so forth. How much energy is available with any nutrient is so critical, because if we have corn silage that we have limited energy availability, then we're going to have to supplement it with something else. Energy measurement is done by a number of ways. It might be done simply as something like total digestible nutrients, or TDN. That's a calculated number recorded in pounds or percent. Or metabolizable energy, which is extremely accurate, where we know what part of the energy fraction is digested at what part of the gut, and that's called nutrient partitioning, a very critical term. TDN, very easy to grasp for students. Typically the metabolizable energy is used much more accurately in today's ration programs because it is much more exact in terms of energy efficiency. If we look then at a few other things in terms of measurement, we can measure calories just like you and I do, megacalories and kilocalories, but understand just very simply that energy is lost somewhere along the line and therefore not digested. We lose energy in fecal matter, we lose energy in urine. When we talk about ruminants especially, they lose energy getting rid of gases or dissipating heat that happens via the fermentation process in the gut, with which we'll talk about later on. Feed analysis, again, as we continue with this, so crucial, because again we can break those energy fractions down into much more specific things, like net energy for maintenance, as you see at the bottom of your slide, net energy for gain. If we're feeding steers, we want to know how much energy in that feed would be dedicated to gaining weight. Or net energy for lactation, which is the last one down here. How much energy in that feed would be dedicated towards milking. Here's a charts and graphs time, a little bit of a flow chart in terms of how energy fractions are broken apart. We can look more at this in class. Feeds and feed composition. Again, we start classifying feeds into dry roughages and forages, which might be like hay and straw. Range, pasture, and green forage gets its own category. Silages then get their own category. There'd be anything as an ensiled, wet, fermented feed. Energy feeds obviously then come next. That would be things like whole-shelled corn, ground corn, cottonseed, wheat, etc. Protein supplements, by definition, carry more than 20% crude protein in them, so the number one and prime example of that would be, of course, soybean meal, that's at 48% crude protein. Also things like fish meal, blood meal, cottonseed meal, linseed meal, things of that are all protein supplements. Mineral supplements obviously are just that, as well as vitamins, and then you have some non-nutritive things like we considered earlier. Generally, in most animal feeding rations, you're going to have a representative of almost every category, except for potentially forages depending on the species. In terms of feeds and feed consumption, again, it's very important to consider there may be a lot of variability. We want to try and predict capability and production of that feed by testing and just experience in different feeding, but just understand that there can be a lot of variability in feed consumption. So some take-home messages here, and I know we've gone quickly through that part of the slide set. Just understand that nutrients and importance is critical to animal productivity. Know what the purpose of every feed that you put in the ration and what it serves. And then lastly, analyze those feeds. I can't emphasize testing importance enough, so that you know that you've put together a proper ration that's balanced and will be effective for you. That ends the first component of Unit 4, Animal Nutrition. We'll come back in the next part, and we'll see you in a second to talk about what feeds would be appropriate for monogastrics and ruminants, and how digestion occurs differently in those two species. Talk to you soon.